Welcome back once again. So in this video, we'll be examining the rules for assigning oxidation number. Now, what's the essence of oxidation number? So one thing you should notice that oxidation number helps you to easily identify a redox reaction. So it helps you to identify whether a reaction is redox or not. So that's the essence of oxidation number. Now, what is an oxidation number before we proceed? An oxidation number of an element in its particular molecule or ion is defined as the electrical charge it appears to have as determined by a set of arbitrary rules. The electrical charge it appears to have as determined by a set of arbitrary rules is the oxidation number of an element. So now these arbitrary rules we are talking about, these are the rules for assigning oxidation number. I listed 7 of them here. These are the rules. Now we'll go through them one by one. So now one of the rules states that all free elements in their own combined state have oxidation number of 0. Are you getting? So now let's go. For example, like sodium now, Na. it has an oxidation number of 0. So you can say Na equals to 0. So in their own combined state, now that is when they are atom, when they are still atom. For example, this is an atom of sodium. Are you getting? In their own combined state, they are 0. So now the same thing goes for chlorine. For Cl equals to 0. For any element you could think of that is standing alone as an atom, their the oxidation number is 0. So that's that. Now another one to note is that the oxidation number of alkali metals in any of their compound is +1. In any of their compound is +1. For example, now we have when you're talking of alkali metals, one of them is lithium, sodium, potassium, lithium, sodium, potassium, rubidium, cesium. Now these are the alkali metals. Now the rule says that in any compound you find alkali metals, that the oxidation number is always +1. So for example, now look at lithium. Okay, let me use sodium chloride for example. This is a compound sodium chloride for example. So now this is an alkali metal, so the oxidation number is +1. Can you see? In any of the compound they appear. For example, sodium hydroxide, the oxidation number of sodium there is +1. So that's the essence of that. So the same thing goes also when we proceed. The oxidation number of alkaline earth metals in any of their compound also is +2. Take note of that. For example, now when you're talking of alkali metals, we are talking of beryllium, you're talking of magnesium, you're talking of strontium. That's okay, that should be Sr. Let me explain that by Sr. These are alkaline earth metals. The oxidation number is +2. The oxidation number is +2. For example, now look at magnesium chloride. Magnesium chloride, MgCl2. Now look at it. This is a compound. Now the oxidation number of magnesium here is +2. Anywhere you find alkaline metals, the oxidation number is always +2. Now another rule says that the oxidation number of a neutral compound is 0. The oxidation number of a neutral compound is 0. So now let's for example now look at when you're talking of a neutral compound, that is a compound that doesn't have any charge. A compound that doesn't have any charge, the oxidation number is 0. Now look at KOH. KOH is a neutral compound. MgCl2 is a neutral compound. Any compound you could think of that doesn't have charge is 0. So now let's go. For example, now the oxidation number is 0. Look at it. For example, that's KOH. KOH equals 0. Can you see? Now if KOH equals 0, what happens is this. And we said this is an alkali metal. We said the oxidation number of alkali metal is +1. So if we go by that one, so we can use this hydroxide ion. If we go by that, we can determine the oxidation number of this OH. Now look at how do we go about that? So if for example now let's say 1 plus OH equals to 0. Can you see? So this K now, the oxidation number is plus 1. 1 plus OH equals to 0. So OH equals 0 minus 1. OH equals minus 1. So which is the oxidation number of OH is minus 1. Now look at it. So plus 1 minus 1. Plus 1 minus 1 will give you 0. So can you see? So the same goes for magnesium chloride too. So MgCl2. If the oxidation number of magnesium is plus 2, and we said it's 0, the oxidation number of the neutral compound is 0. So definitely this has to be minus 2 also. Are you getting it? Now how do we achieve that minus 2? That means chlorine is minus 1. Minus 1 times 2, minus 2, you get 0. So that's how it applies. Further, the oxidation number of the neutral compound is 0. Let me pick it from here. The sum of the oxidation number of all the atoms in a species must be equal to the net charge on the species. For example, now we are talking of the species. For example, now chromium ion Cr2O7 2 minus is an example. An example is chloride ClO3 negative, chloride oxide ion. Another one is ion 3 ion Mv3 plus. Now they said the sum of the oxidation number of all the atoms in a species must be equal to the net charge on the species. Look at Cr2O7 minus. The sum of the oxidation number is equal to the net charge. Now what's the net charge on it? For example, now Cr2O7 2 negative. Now if you go by the example I've been given before, we would have equated it to 0. Are you getting it? So but based on this rule, so the sum of the oxidation number of all the atoms in it must be equal to minus 2 because it's carrying minus 2. So the same goes for ClO3 negative. So ClO3 minus. So the oxidation number, now this here is minus 1 equals minus 1. Are you getting it? So the same, so it continues that way. Now another rule says the oxidation state of hydrogen on this compound is plus 1 except in metallic hydride where it is minus 1. So for example, now let me show you that hydrogen in all its compound wherever you see it. For example, now in hydrogen chloride HCl, the oxidation number of hydrogen is plus 1. Are you getting it? In HCl is plus 1. Now we can determine for chlorine here. So okay, it's plus 1. Any compound you see except in metallic hydride. Now when you are talking of metallic hydride, what are you talking about? For example, now sodium hydride NaH is an example of metallic hydride. So then calcium hydride CaH2 is an example of metallic hydride. So they said the oxidation state of hydrogen on this compound is plus 1 except in metallic hydride where it is minus 1. Are you getting it? Where it is minus 1. So which means here now the oxidation state of hydrogen is minus 1. Are you getting it? Let's say for example now look at NaH. Now let's determine the oxidation number of hydrogen in this hydride. Now look at it. NaH equals 0. Then this is an alkali metal. If we take the oxidation number to be plus 1, so we have plus 1 plus H equals 0. Are you getting it? Now no need of plus 1. That's 1. So now H equals 0 minus 1. So H equals minus 1. So you can see that the oxidation number of hydrogen here is minus 1. Let's continue. Now the same goes. Now I've shown you metallic hydride. That's NaH CaH2. So that's that. Now the oxidation state of oxygen in all its compound is minus 2, except in peroxide. Where it is minus 1. For example, in all its compound, think of it: carbon 4 oxide CO2. Where can we see oxygen again? Na2CO3. Now the oxidation number of oxygen here is minus 2. Here is minus 2 also, wherever you see it. So, but in metallic hydride, in peroxide, it is known as minus 1. So these are peroxide. An example is Na2O2. Another example is A2O2. Another example is Ba2O2. These are peroxide. You will see in peroxide oxygen. You will see. Look at here. The metal is two atoms of the metal, 2 atoms of oxygen, 2 atoms of the metal also, 2 atoms of oxygen. This is peroxide. So in all peroxide, you see the oxidation number of oxygen is always minus 1. So thanks for listening. So in the next video, we'll continue about oxidation and reduction and do further more on it. I am Dr. K. Don't forget to subscribe and share with others. Bye.